So here's the program that you can use to interface to an LCD. Now you'll have this code right in your lab handout, so you can copy and paste it electronically. Don't retype all of this; that isn't worth your time. What you can see here is that the very first line, well, the very first non-commented line, is extremely important. This is a library called liquidcrystal.h. The H actually stands for header, so this is actually a header file that specifies all the functions that are built in to the Liquid Crystal library. Now, if we didn't have this, basically today's lab would be infeasible. It would mean that you would need hours and hours to write all of the necessary functions to interface to a liquid crystal display. Definitely wouldn't be worth your time. But the good news is that anything that you really care about is almost certainly going to have library functions already written for it. So we want to get you started early in expecting that there will be library functions and learning where they're located and how to find them and how to use them. In our case, the liquid crystal header display function is included here. It's included in the Arduino interface, in the Arduino integrated development environment, and there's a website down at the bottom here, this one right here, that shows you exactly what the reference for that liquid crystal library is. There are actually 20 functions built into it, and we're not using nearly all of them in this example. The next line here is going to specify that we're going to have an object called LCD, and that LCD is going to be of type liquid crystal, and we're going to make these connections to it. So when you hook up your hardware, you'll have 6 wires to connect to pins 12, 11, 5, 4, 3, and 2 of the Arduino. And what we're specifying here is that those connections are being made to those pins. We don't have to use those 6 pins, but since we are using them, we have to specify which 6 pins we're connecting to. So those are at the very beginning, before we even get into setup. Now setup is going to clarify that we're going to have an LCD screen that has 16 characters on 2 rows. So there's going to be 16 characters on the first row and 16 characters on the second row. And you're going to find that we're going to number the rows and the characters starting with 0. So the top row is going to be row number 0. The second row is going to be row number 1. Similarly, the leftmost character, the leftmost column, is going to be character number 0. It'll go up to character number 15. I want to go ahead and clear the LCD because it's possible that something was already on there from a previous program. We want to go ahead and wipe that out, make sure that it erases everything that's on the screen. And we're just going to print the words "Hello World." That's kind of a traditional, very first thing to have the computer display. So we're going to go ahead and do that. Now notice that as soon as we just say print, it's going to print wherever the cursor is currently located. But when we cleared the program, it placed the cursor at the top left corner. So everything is going to be interfacing from the top left corner, and Hello World is going to appear then on the top row, row number 0, on the far left side. Now once we go into loop here, remember that loop will execute over and over and over again. We want to now set the cursor location. We're going to set that cursor location to column 0, so on the far left side of row 1, which is to say the second row. Remember that the top row is row 0 and the second row is row 1. So what we're doing is basically putting the cursor in the bottom left-hand corner of the screen. Now we're going to print something to that bottom left-hand corner. So we're going to say again LCD print. Remember that that's the same function that we had up here for Hello World. So now we're going to say LCD print, and what we're going to print is millis divided by 1,000. Now millis is a built-in function that we haven't talked about yet, but the Arduino keeps track of how many milliseconds have elapsed since the last time the Arduino was reset. And so in this case, when we divide that by 1,000, what we're going to get is the number of seconds that have elapsed since the Arduino was last reset. So when we verify this program, which I'm doing right now, and as soon as it's verified, I'm going to go ahead and upload it. When I verify and upload this program, what I should get is in the top row of the LCD screen, I should get the words "Hello World," and then on the bottom row, I should get a number that starts at 0 and is going to be incrementing once a second for as long as the Arduino is turned on until it's reset again. If I upload it again a second time, then it's going to reset the Arduino, and that's going to reset the count back to 0. So what we've seen here is we have the ability to set up the liquid crystal display, to initialize it to be 16 by 2. We can clear the entire screen, we can print a message, and we can adjust the location where that message is going to be printed. Now you might say, what if I didn't want to erase the entire screen? Well, then just print spaces. If you wanted to erase just the bottom row, you could set the cursor to appear on the bottom left-hand corner and then print, say, 16 spaces, and that will wipe out the entire bottom row.